So, before we create our own climb system, like this, okay, I thought we should probably do a bit of a breakdown of other popular climb system mechanics, just so that we know how this will work, and basically so that we are on the same page on what we're going to do, since there are a couple of different climb systems. And on another video, so subscribe for that if you haven't already, we're going to actually see how to write our own climb system mechanics and how to integrate it on the third person shooter. I'm basically going to build it on the project we have on our third person shooter, but also keep it as a different project, since this is not even since it's not even related to just a third person shooter. It could do for any third person game. Now, if you have the third person shooter project, it's going to be included over there, so do not worry about that. Now, let's go to our first candidate. Now, the first candidate we're going to look to, or the first climb system, if you will, that we're going to look to will be Splinter Cell Blacklist. And I kind of intentionally picked this game since they are both from the same publisher. So yeah, and the other known climb system we're going to see. Now, excuse some frame drops you will be seeing. I'm recording a video after all and playing another one, so yeah. So first of all, what I'm looking at is how we actually start enabling the climb mode. Okay, so in the case of Splinter Cell, it's pretty much the same thing as always, and in Assassin's Creed it's also the same. When you go near a wall, you start seeing indicators, and if you press Q into this wall or whatever, you get into a cover position. Now, yeah, just move around over there. Now, of course, this is going to be the worst let's play game you will ever see, the worst video. But anyway, now we started on the climb mode. Two things we spot directly is that you see over here we grab he grabs over here, and another thing I want you to notice is that his hands are opposite, or his whole posture is like this. Now I'm pressing, I want to look exactly how it moves. So I'm pressing only one button at a time. Okay, and I mean just a single touch, and see what exactly happened. In this case, the character moved about this much. And okay, and from both ways it will work the same. With just simple taps, we are going from one way and we're moving a little bit to one point and a little bit to the other. So, and yeah, so probably get a little bit back. The furthest point we can reach will be somewhere around over here, probably, and it might even be this one, and somewhere around over here. So, just with that, what we can directly say to this and how we can see it is just simple interpolation. And since the place we actually started grabbing seemed kind of random, or at least it felt random, now you will see that it did a bigger jump over here instead of the simple tags. It's because I kept the right button instead of just a gentle touch. Okay, the same thing, the same thing applies. And you will notice that there's some cases that the right hand might look not natural, or it looks like it's the animation blending to the idle state, which is always and always, which is always with the hands apart. Okay, same way over here for more cases. Now there is a case that, and the other thing I want you to see is the way I moved from 1 to 1 was simply an interpolation, and you will see that it didn't even take into account the corner. So the maximum should be somewhere over here. You can move in this case. Okay, and it jumps directly from one to the other. Back down again, and it seems that it moved from the endpoint directly to an endpoint, and when I keep left, so I wanted to go over here, but he just jumped across like this. Okay, so basically it's not even that detailed, so that you can go directly to the edge. Okay, simple stuff. If I want to go up over here, I only have to press space. Same way like this, and from over here you see that there is this climb thing where he jumps. The whole thing was pretty fluid. Okay, I didn't have to press anything. So directly with this, what we can get straight out of that is that you can have a lerp from one point to the other, and a lerp from one point to wherever this ends. Okay, and you can have another lerp, which is automatically this lerp, that moves from one point, from one ledge or the other ledge, if you want to call it like that. Okay, and back again, back again. So in this case, we can have, there's basically one over here, and one hole from beneath. Okay, so you can think of them not exactly like lerps or like a network basically, but I do not want to use the word network for this. We will see, you will see why I do not want to use that. Okay, so as far as this climb system is concerned, I think with just a few lerps you can pretty much get away with it, since basically if you want to go up or down, it's just space. If it has directly above him, if you can find a ledge or a climbing position anyway, okay, then that means you can go up and you can go down. From what I've noticed, there wasn't so much of diagonal movement, unless I missed that, since this map didn't have a lot of stuff. Okay, and over here I'm trying to find, if you press, yeah, like that, if you've noticed that, if you are pressing not to climb up, okay, if it's over here, you can say that, if you say you have a collider like this, you can indicate that there's no top from this ledge, so just go and over the ledge, just climb. Okay, do another behavior. And if you're pressing one to go to one direction and immediately follow it with going to the other direction, you will see that it automatically cancels that movement. So I press to go over here and it immediately press to go to the other, and it cancels that movement. And that's going to be important, since the we will see in a bit why that it's important. Now, so what things we should keep in mind with that? climbing from point to point, it's linear. It's basically an interpolation. Okay, and you can go, you have a variable of positions to be placed upon. So you basically you have an interpolation. You can have the percentage, yeah, not just from 0, you can have it from anything. Okay, but let's just use 1 and 0 and 1, so that we are more focused. Okay, so to move on a climbing system, you simply just interpolate into values. This would be 4. Okay, and moving that. And if you're also moving, yeah, you can use with the same speed, depending, and no matter how big your lerp will be, you will always be moving the same speed. Okay, and it will have your this movement. This, yeah, you can move on a ledge. Now, I think I've covered everything I had to cover over here. You will also notice that from this point to this point, it goes instead of going straight down, it kind of goes diagonally. And this could be either because they have they do the positions, so it's not actually variable positions. Okay, it could be something like this. So on whatever position, when you're trying to climb the ledge, okay, it's going to be fixed on any of those positions and not the in-betweens. Okay, simple stuff. You just find the closest one, the closest point. Okay, simple math basically, and make him go over there. Now, as far as the animations are concerned, we're not going to focus at all at animation, so don't mind what this guy does. We're only focusing on the route, which on this case the route should probably be either on his waist or on his feet, although I think it's probably I think it should be on the legs, and this will come into play later. Okay, you will see, as I said, diagonally it always falls at the same position. That means we have fixed positions instead of variables. It's just that all these positions are so many that that it looks like it's a variable position, but basically what you're going is from point 1 to other to other to other to other and so on. Now let's go to the other game, and of course this is Assassin's Creed. Sorry for it's kind of dark, and I noticed after I've recorded, and I didn't really care to play it again anyway. So okay, this is Assassin's Creed Rogue. It just was on sale, so not just, it was on the summer sale, so I just picked it up. Now we will start the same way as to find how we actually initiate the climb mechanic. The climb mechanic in Assassin's Creed, and probably in all the other Assassin's Creeds, starts if you start walking on a wall. If you are holding down space or shift, I think, I don't remember what key, only then you are going to climb up. If you do not, then you're going to touch the wall or just sit on the wall, just do something idle. Now there is another case that when you are close to a corner, and you will see that there's a bug over here, and I think it's in the video, it takes it so that it's like a corner, and so the character sits over here. I know you are impressed with my drawing abilities. Okay, he sits over here and he starts looking towards the guy, and of course if another guy comes over here and walks, then he's doing his animations and something like that, and you know, he kills him. If you also want drawing lessons, we could do something about that. Okay, yeah, anyway, just a side. And let's move on a bit, because yeah, here is the bug as told you. Okay, he's picking on a corner, but this is a door, so I don't know what he's picking at. But bugs like this can be pretty helpful a lot of the times, since this way you can start guessing what this works, how this works. So just seeing this, I think there's probably some procedural placement that places triggers or stuff like that. I guess you can say triggers. So yeah, so what we can take from that, from just that bug, is that probably there is an algorithm that might create triggers for the corners, or they just use a prefab for all this, and whoever placed it didn't look it or go it away, or they might just want to have them. Okay, now the important thing to say that if it's procedural, that means all the other points we're going to see, they are both procedural too. Okay, so keep that in mind. Now let's start with the climbing position. Directly started, climbed, and we moved on this position. Let's watch a bit. I'm trying to see, every time I'm trying to climb, at what position he's actually starting at. You will notice the same position. The other thing I want you to watch is that his hands are actually joined in together. Now let's move on. Here's one other thing. Now on Splinter Cell, for example, we wanted to move up and down. We had to hit Q or space. In this one, if I press down, you will notice that he doesn't actually move. He moved first his hand. Now, if I keep pressing down or press another button that isn't the up, he will move to the down position again with the hands closed. Okay, this is the important thing. And here's where the actually fun stuff works. Count how many times his hands join together, as far as this door is concerned. Okay, it's 1, 2, and 3. In this case, it's more of the same logic like this. You will notice that they pretty much look like they have the same distance also. And the other thing that I've noticed that was pretty interesting is, even if I hit just for a little bit the direction key, or even if I hit if I kept it down, okay, then he will always do the same thing. It's not like he will play a different animation like it was in Splinter Cell. It will always do the exact same thing, to move his hands first like this, and then close them. And here's the other interesting thing is between the two states, or three states if you will, we have when he's at this point, and you can try that on the Assassin's Creed game, probably you know all the Assassin's Creed games. If I press a key right now, then it will either only move back or forward. You cannot go up and you also cannot go down. So what this tells us? And here's where we can actually start the breakdown. That tells us that there is two cases or two states if you will. One that has the closed hands and one that has the hands open. So we can pretty much name them. The state which has the hands together, we can call that the point state or something like that or whatever, and this state we can call it the transition state. Okay, the important thing and the interesting thing, I thought it was kind of interesting to be honest, is that from this state, from the transition state, you cannot go into any other point states. So the climb system that felt so open and so open world, we pretty much boiled it down that you can only move on other points when you have your hands together. So from this point I can go to this point, to this point, to this point, and yeah, I think you can actually go this way and this way and this way. Okay, we counted, so it's 3, and of course I can also fall down, and from one point to another I can also go to another and to another. Now there is a case of I can actually climb in this thing over here, okay, even if it's on this angle, but it's still the same principles apply. One transition state, which is this, and one transition one point state which has his hands together. Now the important thing to note is in this case it's the root of the character, not the feet, not the hands, and that's why, because they use a lot of AK in most cases. Okay, because yeah, it looks better if you use AK to place the hands actually, but you will notice that in this case that had the hands like that, as you saw, he has the one hand on one point and the other hand to the other point. Okay, and that is why we cannot really use the we can't use the position of the hands or the position of the feet in that matter. The root will always be the same. Not the same, the correct position. What gives away basically the position. So from one point to the other, we'll be looking only at this position, the root position. So when we want to lerp our character from one point to the other, we're going to lerp him based on the position of his butt over here. Okay, and of course this does not need to be a linear interpolation. We can actually add overshoot or anticipate. We can actually add spring. We can actually add spring, or I think spring. Anyway, we can actually add a lot of stuff there. So boiled down, basically this is what we need. We have the basics of the bare bones skeleton, if you will. You basically have a grid, and you either at the end of the grid, at the point inside the grid, where it means you can actually move into another position, like this, or you are inside a transition, like this. If your character is inside the transition, you can either move into the previous one or to the next point. You cannot move to another point that is outside of his outside of the current active lerp, if you will. And yeah, it might look confusing or weird, but you will notice it when we actually see the code on the next video. The code we are going to write, okay? Or everything in here is just observations based on gameplay. So when we actually write our own code, then you will see how easy it is to separate it up, because otherwise it just look like it was pretty much you can do everything you want about on it. And a lot of other climb systems I see, they use a lot of the physics and the box colliders and all that, which yeah, it might work, but it's, I don't know, it doesn't feel as fluid and as nice as this or all of it. Now let me try and find another case. So as I was saying, between points, since this is interpolation between 2 points, the distance doesn't matter. It will always try and find the middle point. So in a transition, of course, this where the actual point is, where let's say the hands will go, and you have to keep in mind the, let's find it a bit, you have to keep in mind the offset of his root bone or his hips over here, like this. Okay, he was going from one point to the other. He started, his root position was like this, and his now is at this point, or he may be even lower, I guess. Yes, well, he was probably somewhere over here. Okay, when I go on the top point, his root bone will probably be around over here or even over here. So what this does is the point it is over here is actually the middle point between the target, let's call this the target point, and the starting point. And I probably go up at some point. Yeah, okay, you will see that he actually went there. Now there was that case that he went up and he was standing on 2 feet, and I'm trying to recreate it, that the thing that he was standing on 2 feet, but you will see that even with so many attempts I couldn't even do it. And here's the other interesting part. Okay, still the same principle applies, even if they are not on the same direction. Still the same position. His root is going always at the middle. And in this case, the hands not being on the same position, being split or at the same position, could all be IK and not even an animation. And you will see that probably IK positions are recalculated, and that's why I told you to not look at the positions of the hands, since always the root will always be at the same position. Okay, and you will notice that this wasn't at the same position. oops. Let's move on. And here's another interesting thing. So when I wanted to move from here to up here, okay, everything breaks down because it's not the same. There wasn't any transition state, the one we had. It went directly from point 1 to point 2. So what that does tell us is that we not only have two states, we have the two states like this, transition point and point, but we also have transition types. I'm not going to write types. So what the two types I've noticed are: one is simple interpolation that has, or let's just say it, one is of type of two steps interpolation. So it goes from, if this is 1 and this is 0, it will first move to 0.5 when we are in the middle, and then move on to 1. But the previous case we saw, okay, starting position, so this is 1, this is 0, ending position, this is 1. So we have two step and one step, and this is important. If I want to move down or up, it's the same principle. Okay, nothing is recalculated, nothing uses physics, it's all grid based. Imagine it like doing pathfinding on a grid that of course is not a square grid, and in that pathfinding, you only move one node at a time. In our case, the nodes we are moving are the climb positions where he has his hands together. If he doesn't have the hands together to move from one point to another, you have two ways of moving, either with two steps or one step. Okay. The other case also that you will notice that on some other cases that let's just see it in a bit. Okay, still the same principle. One point over here, one point over here. Middle point, his hands are wide and his hands are down. Of course, there is the case that at one point you can only move into another point with the one step transition instead of two. You will note that. This kinda gives it away. The way he jumped over here, it kinda gives it away because it wasn't natural at all. It gives away that the whole thing is based on interpolations. Okay. There's no way somebody will jump that straight. It just doesn't happen. Okay, simple enough, clever system, and you will notice that even if it's this small of an object, we can move the same way. It's always 2 points, even if it's too small. Like if it's smaller than this distance, so if it's like that and that, it's just a 1 point solution, so they do not even use it anywhere else. Now, of course, this comes the point where this, to be set it up by hand, it's kind of tricky and it's kind of a lot of work, but this could be two things. From one, it's a AAA studio, of course, so they have the resources to just put people to make them, to make the prefabs one by one single-handedly. And there's also the case that they have something automated, and here's where the bug with the corner come into play that I said. Okay, so if that was the case, so if it wasn't an error or somebody missed that, then that means that they have something procedurally created. Of course, all this is just based on observations, so I wouldn't actually know what happens exactly. Okay, everything we said. Now, the other case like this is that it's actually on the edge of the LEDs. Okay, so it's when we are pressing up, you actually just do an interpolation, a one-step interpolation, and you are back on your feet again, and you are happy, you have your sword out or whatever. Like this. Falling back, it's still the same, although you probably have a trigger or something that indicates you are actually falling. And you actually, when you are not on the ground, you can actually start doing a trigger to see if there is a collider or something that you can grab on, but something we should probably look on our own system. Okay, let's move on. Still the same. Okay, I'm just trying stuff. Now the other thing I noticed is that over here I can climb from one point. Yeah, this is still the same. Okay, you clearly see the point. You clearly see the downwards point. Although in this case there's not really any need for being in the middle of two. And this one, you can't. I kind of think you can write this thing so that it offsets. It finds the IK positions for the legs. Okay, it's nothing special, just to raycast. And if it's lower than a threshold for the hands, lower than the threshold you have set it for the feet, then you just add a little bit of offset on his root bone, and he looks like he's standing up. Okay, and since you are using IK, there's not so much stuff to do. Now, the other thing I noticed is that from this point, even if you are holding down the space from over here, you cannot actually climb. So this is probably a bug. Well, yeah, it's a bug, not probably. And this is another thing that made me think that they might have something that automatically places positions here and there. Since, yeah, if they had one collider from over here to the other that said that you can start actually making climbing up or initiate climbing, then this shouldn't happen. But since it happens, they either have something that made this happen, or there is also the case, now that I think of it, that there is a collider on the window, and that collider has problems or interferes with the whole start of the climbing. But you will see that from the edge I can actually climb. So yeah, it might probably be prefabs with a window or something like that. And another case is that I'm not entirely sure if they're using IK or not, because you will notice that his feet over here is actually sitting on the air. You can notice. Now, here's the thing though. This is a special case, or the seats over here. If you try and walk from there, he will actually do something like a cutscene that he kneels a bit, or he crouches a bit so that he can pass from above. So there's probably a trigger collider over here that initiates that cutscene, I guess you can say cutscene, and does that. And the IK looks this and thinks this is a wall, so it places his feet over there. Okay, and another thing I noticed, even though I can walk from this point to this point, I can climb between here. When I'm jumping from one of the point to this point, well, not to this point, to this ledge, I always fall at this point over here. And that's what I'm trying to find again and again. Okay, if it's repeated results, that means it's not something random. It always happens on the same position, so that makes us think that it's the way it's supposed to work. Now, why this happens, your guess is as good as any. It could be something automated, it could be something that is not automated. I really don't know and can't know for sure. Now, I've seen though some videos that I think they have some procedural stuff, that not procedural exactly, but they have some building editors and all that. I think they used it on The Division. It was a video about The Division, so they might as well just use it for this. I really don't know. Okay, same stuff. This is another case, of course, where it's look kinda weird because of the angle, and he's actually sitting on nowhere. His hands are below the rope, and we have a curious guy over here. Well, let's make him something like that. Okay. Now, it's mostly just playing around like this. Okay, we see the same stuff everywhere. Two positions, two states, point, transition, point. Or the jumping about, jumping around, and so on. So, in the case of this angle, it means that you have a point, transition, point, 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 point. Okay, and you move with a two-step transition between each one. Okay, repeated patterns. Since if you can find the repeated patterns, that is a gold mine. Basically, you pretty much have understanding the climb system. And since I find that it has a lot of repeated patterns, there might be some slight variations or randomness at some points, but that could be intentionally, and that could be programmed. You can write that pretty easy, so we do not even worry about that. Okay, of course you will notice that it's not always that perfect. Like this, it's kind of unnatural if you think his knee is over here, his patella is over here. He probably will have been screaming in pain if he had his leg like that. Or anyway, I might be wrong, of course. And okay, same patterns. You can actually, even eyeballing it, you can actually even split the positions. He can be. So this will be like this, and if you want to go up and that. Here's another thing. I can actually climb a fall into this place, so that tells me that when you are moving on the wall and you start climb, it first checks if it's a ledge. If it's a ledge, that you can go directly without having to climb. Okay, if it's not, then it's going to fall onto the climb like we did on this wall. But if you are moving from the other side, if you are moving from over here to falling down, it actually doesn't do any depth check, if you want to call it like that. So he's going to fall and grab like this. Okay, we're just gathering info basically, or resources, if you want to call it like that, to understand what we can do, what goes around in other games, what has already been done, since okay, there's no need to reinvent the wheel. And I actually think there is an Assassin's Creed made in Unity, not the Assassin's Creed Unity, another one for mobile though. And here's another interesting part. I move from here to here. Logically, you should probably have been moved into this ledge instead of that ledge. So having the point system from point 1 to point with transition, and having a point that can connect to other points, to whatever point we want. Okay, and it doesn't matter the direction, or if it's front or back. Okay, since your characters have two axes, of movement, so your input is two axes, which can control pretty much 360 degrees on 2 dimensions. If you notice, if you have to jump backwards, you have to keep space. So what does that tell us? Now, there's no video, I haven't write the video with it, just know it from experience. What this tells us is that when you are pressing, okay, you have your normal axis when you are moving the input, which is 2-dimensional like this, and in Unity the up will be the Y and this will be the X. Okay, so when you are normally climbing from point to point, you have this direction, but if you press space or the equivalent, it actually takes this vector and looks, instead of looking at the Y vector, it looks at the Z and probably either X, although I think it's probably it looks on the Y vector. Yeah, probably not on the Y, since if you press the up it looks on the Y, so it probably looks on the Z and the X, but we will see that on example on by code. Okay, so you basically just take the input of your character. Let's give him a cape because I just thought of it. Okay, you just take the input of your character and pretty much change it to have directions, to change it into a direction you can have. So let's go find my grid again, or something that we can create a grid again, and I'm pretty much almost finished. So we have a point over here, a point over here, okay, points all around and all around. Since I only move from point to point and not into transitions, this makes our life a lot of easier. So we can have our current active point, and we can have references to what point we are actually connected to. And all this doesn't even have to be generated at runtime. This will always be positions, references be set in, they can always be set up from the editor, and then you wouldn't even have to write a lot of code afterwards. So, okay, this is the current point, and I have the references to what points I can actually jump to. So I take my input, okay, in our case that will be an y and an x axis, and the only thing we have to turn that is to turn the input into direction. Okay, so if my y and x axis says that a direction should be a vector 3, so yeah, a vector 3 even though it's two-dimensional. Okay, so if our input turn into a direction that is 0, 1, 0, that means it's this point. If it's the x is the first one, x 0, 0, it's this one, minus 1, okay, 1 on the y, or if you want to call it 1, 0 on the, yeah, this will probably be 0, 1, minus 1, 0, 1, 0. So you basically have a vector. What a nice straight line. Okay, you have a vector, the center point is your current active point, and finding out all the other points is just simple math. Whichever direction, whichever point is closer to the direction we are passing from the input, then that is the current active point we want to move. Check the transition, what kind of transition we can have. This can be even automated, so you check the distance. If the distance is too small, then do a 2-step. If the distance is greater than a threshold of our distance, make a 1-step transition, and so on. Okay, so we pretty much boiled it down, did a breakdown of the system. So the only thing left to do is to actually go and write it. But that's a story for another time. Now, let's see some other cases of climb systems. Now there's some other cases, as I said, of climb systems like Shadow of the Colossus. Now from what I can tell, this could be a linear interpolation, but this I think I know, I've read somewhere that this is actually a ragdoll or something like a ragdoll, so I don't exactly know, I haven't thought of this. Now of course it's going to a whole different subject and a whole different system, and I think when you are actually like this, when you are actually climbing on top of his back, the whole system of course is different, it's all variable, there's no point to point, you can move anywhere you can, and that's probably why there's probably a collider behind it or somewhere where the whole fur is, and they have the fur over there because they probably do not have the hands attached that well upon his back, so the fur just hides the offset of the position from the hands or feet. Okay, but that of course is a story for another time, and we might see this in the future. I do not know for sure. We might make a climb system like this. We will see. And another one that has a cool climb system that I thought it would deserve a mention is Dragon's Dogma, which also has, yeah, I've played this one. I haven't actually played Shadow of the Colossus. Yeah, I know, I'm horrible. And this one has a pretty interesting thing that I don't know if I can find a picture, and I don't know if you can actually see it. This probably from YouTube, but yeah, you can see that you can actually climb on top of the whole monster. You can even climb on the hands. Of course, the easier you climb, the easier you're going to. And yeah, this deltoid doesn't look that well. So yeah, I guess you can say it looks well anyway. Okay, you can actually climb everywhere, and you can, I think you can attack specific position, although I don't remember if you can attack the eyes exactly, but I think you can cut legs and stuff like that. Like, I think, oops, in there was a chimera, or however you call that in English, that you actually, yeah, I think this one will show. Yeah. I do not care that much, so that I'll wait to load it. Okay, there was the, you can actually cut tails of or heads of monsters and all that. So yeah, that's a whole different story. You could actually climb on dragons and all that. It was actually pretty cool. Or griffins. Yeah, I think if this one loads, yeah, this is another very interesting one. Okay, you actually, he's actually clipping through the body, so that's probably an error. But you can actually climb on top of the whole monster. So in this case, they probably do stuff with the colliders. So this has something like, probably, okay, as I said, this is just an observation. Based on observation, I do not know and never look at codes. And it probably has something like a ragdoll, and you have the colliders of the players, and you make them stick to the colliders of the ragdoll. Okay, or where you can actually climb or not. And there's of course the cases with another case. Okay, we're simply just seeing cases for climb systems. Let's say, I think God of War had, yeah, it's pretty simple, or like this if you will. It's a special area or a special glider, you can call it whatever you want, that you can only, or yeah, probably this looks like this, and this stuff have their own colliders to block your way, and you can move into every position you have over here, so it's not point to point. Okay, it's more freely if you will, but it also doesn't look that fluid as it does in Assassin's Creed. And yeah, I think there was one in Castlevania, the newer ones, the 3D ones. I don't know, Lords of Shadows, I think. Probably this one, yeah. Yeah, this was very simple. Linear interpolation, and not even just basic linear interpolation. If you have a linear or if you are in range of the other connected linear interpolation, then you can move into there. They also had, I think on some special bosses you could climb, but yeah, or like this. Oh no, this is a level like this. I don't even remember. Oh yeah, like this. I think no, this is not boss, or I cannot tell. Like you have your lines over here, you can actually see them. They didn't even bother to hide it, and you can move from one to the other and to the other. So I'm actually going to end the video. No, before I'm ending the video, and I think there was something like a mill or something. Yeah, I cannot find it now. I thought I've taken a picture of it, but video of it. But anyway, let's do a quick rundown. You have, let's move to something less disturbing. You have point, points, points everywhere. Okay, you have your current point. If I want to move from this point to this point, I check the distance. If it's greater than our threshold, which in this case it is, then you do an one-step transition. So it goes and jumps directly there. If I want to move from this point, from the current point to this point, of course the distance is always lower than the threshold, then we have a two-step transition. Same with this two-step transition. You can think of the two-step transition that the player has to press the button for more than a fraction of a second. Okay, or if he's keep pressing the button, then it takes it as a second input. To find from which point to what point I want to jump to, I take my input. The default axis will be, the default axis we are looking for will be y and x, or x and y. If I'm pressing space, will be the x and z. Okay, or something like this. Not exact, it might not be exactly x and z. Okay, and then compare my direction with to what point corresponds, and the one that is closest, I'll take that as my target point. So I'm actually going to end the video now. You know what to do. Subscribe, like, of course, if you liked it or if you disliked it, and always, if you liked the content and want to see more, and you want to see more content earlier than they go live on YouTube, then consider supporting me on Patreon. And of course, on the next part, we are going to make our own climb system, climb game, and we're going to implement it on our third-person shooter. So I'll see you next time.